Hi, my name is Mr. D, and today I want to take a look at finding the derivative of an exponential function. So we have let y equal x to the x power, and we want to find dy dx. So to answer this problem, we're going to need to know how to use log properties, the chain rule, the product rule, and we need to know the derivative of the natural log function. So the first thing we can do, for step 1, we have y equals x to the x power. Whenever we're finding the derivative of a function whose variable is an exponent, we usually want to take the natural log of both sides. So we could take the natural log of y and the natural log of x to the x. And what this allows us to do is, on the right hand side, we could use log properties, the exponent property, to bring this exponent x in front of the natural log function. So for step 2, we're looking at ln of y equals, and we have x times ln of x. So all we did was take this exponent of x and bring it in front of the natural log, because this is a property of logs. But now the goal is to find dy dx. So what we need to do at this step is take the derivative with respect to x of both sides. So we're taking d dx of the left hand side and the right hand side. But notice right away that we run into problems on the left hand side. We cannot take the derivative with respect to x of the natural log of y because the variables do not match. So at this step, we do need to make use of the chain rule. So for step 3, instead of d dx of ln y, we could write d dy of ln y times dy dx. One way that helped me understand this chain rule is think of the the dy's as canceling out, and it brings you right back to d dx. We can find the derivative with respect to y of ln y, so that's why we use the chain rule at this step. And this is equal to d dx of x ln x. So for the next step, what we're going to do is we're going to take the derivative of each of these pieces. So on the left hand side, d dy of the natural log of y, using our derivative for the natural log, is simply 1 over y. So d dy of the natural log of y is 1 over y times dy dx. And now we have equals, and this is where we're going to use the product rule. We're taking the derivative with respect to x of x ln x. So if we treat this piece as the function u, that is, we will call x our function u and ln x our function v, all we're doing is we have u prime v. So the derivative of x is 1 times v, which is our function ln of x, plus, and now we have uv prime. So we have u, our function u is x, times v prime. The derivative of ln x is 1 over x. So all we did at this step was use the product rule on x ln x. So for step 5, what we need to do is we're just going to simplify everything. Now we have 1 over y times dy dx equals, now 1 times ln x is ln x, plus, now x times 1 over x is equal to 1. So we're almost done with solving this problem. I'm going to write this expression, natural log of x plus 1, to the right a little bit. So we have ln of x plus 1. But now to solve for dy dx, all we need to do is multiply both sides by y. So we're going to multiply the left-hand side by y and the right-hand side. Notice that y times 1 over y cancels out. So for our last line, we have dy dx equals, and now instead of writing y times ln x plus 1, we're going to substitute for y, because our answer does need to be in terms of x. So instead of y equals x to the x power, And now inside the parentheses we have ln of x plus 1. So just to summarize, the derivative of our equation y equals x to the x is x to the x times the natural log of x plus 1. Okay, well this is going to conclude this video on finding the derivative of an exponential function. Thank you all for watching, and I hope that this was helpful.